Hello everyone, welcome to my channel. I have started a personal DSA challenge where I am solving 5 problems per pattern, covering 180 problems in total. I'll be posting one video per day explaining my thought process from brute force to optimized approach. If you are new here, you can check out the previous videos to follow along. In today's video, we will work on longest substring without repeating characters. So the problem states that we are given a string S and we need to find the length of the longest substring that contains no repeating characters. So a substring must be continuous and each character should appear only once in that substring. So let's start with the brute force approach. The idea here is simple. We will try all the possible substrings and for each substring we check whether it has all unique characters. If it does, we calculate its length and update the maximum answer. For that, we need to initialize a variable to track the maximum length. And we will be iterating all over the array, all over the given string. Dot length. And j starts from I till the end. Now, since we are looking only for the unique substrings, let's initialize a set here of type character named set. Set. Now we will check if the current character is present in the set. Char j. If it is, then we will break. Otherwise, we will add it to the set. And we will also calculate the maximum length, which would be the maximum length and the current length, which is nothing but j minus I plus 1. At the end, we will return the maximum length. Let's run the code. It is working. So the time complexity would be O of n square because we are iterating through two for loops, one in the other, and the space complexity would be O of n because of the set. So this code works, but it is not optimal for larger strings. So the optimized approach would be we will be using a sliding window. So now let's move to the optimized approach using the sliding window technique. Here, instead of restarting for every substring, we maintain a window of unique characters and we use two pointers left and right, where left is the start of the window and right is the end of the window. And if we encounter any duplicate characters, we would shrink the window from the left until the duplicate is removed. So for that, the optimized code would be like, as usual, we need set as we are looking for unique, and we need left and right, where left would be 0, and we need max length, which is 0, and we would iterate the for loop using the right pointer, which initially starts at 0 and it iterates till the length of the string, and right plus plus. And now until the set contains the right character, we would remove the left one, and we would increment the left pointer. So we will check while set contains the right character, we would remove it we would remove the left character and we would increment the left. So until the duplicate is removed, this while loop iterates, and after that we would add it to the set. If it is not present in the set, and we'll calculate the maximum length like this. But here J and I would be right and left. And at the end we would return max length. Let's run the code. Okay, let's submit it. Alright, so let's quickly dry run for this input. So we expand the window until a duplicate appears, and when a duplicate appears we will move left forward, and at every step we track the maximum window size. So the longest substring without repeating characters would be A, B and C. So initially left is here and right is also here, and then we will add this to the set, we will add B to the set, we will add C to the set, we will add A to the set, but we will not add A to the set because it is a duplicate. So we will shrink the left pointer, and then we will shrink, and at the end we will add this ABC, and again since this BB are duplicates we will not add them. So the answer would be ABC, and the length of this is 3. Okay, and BCA is also correct and CAB would also be correct, but since the length of these three substrings are 3, we would consider the length as 3. So the time complexity for this would be O of n, because we are doing it in a single pass in the for loop, and the space complexity would be O of n because of the set which we used. So that's how we move from brute force to optimized approach using the sliding window technique. And the sliding window pattern is extremely important, and it appears in many strings and array problems. So yeah, that is it for today's problem. In the next problem we will continue with another sliding window problem. Thank you for watching.